Okay, everybody, welcome to section 2.3, talking about higher order derivatives. Okay, so at the end of this lesson, we should be able to find higher order derivatives when given a function and make interpretations of these higher order derivatives in context of situations. So let's check out what higher order derivatives mean. So lately we've been talking about derivatives, right? Just find the derivative, right? So because a derivative of a function is itself a function, right? It's still a function. We can also find the derivative of that derivative, which is then called the second derivative. And it is denoted as this. We say f double prime of x, f double prime, right? So, and if you think about it, if we can take a derivative of a derivative to get the second derivative, right? That means we can take a derivative of the second derivative and get the third derivative. So we can take an infinitely amount of higher order derivatives, as you could see. So there's the first derivative, what we've been working with lately. We can take a second derivative. We can take a third derivative. We can take a fourth derivative, right? We can do that. And we can take the hundredth, thousandth, and then theoretically nth derivative of f. Okay, so let's go ahead and check out an example where we're going to take more than one derivative. So if you look at example one, we're given a function f of x equals 2x to the fifth minus 3x to the fourth plus 5x squared minus 6x plus 7. And the question is asking us to find the first, second, third, and fourth derivatives. So, all right, first, second, third, and fourth derivatives, right? So we're just going to keep taking the derivative of this thing. So let me kind of rewrite the function here. It makes it easier for us to see. But we have f of x equals 2x to the fifth minus 3x to the fourth plus 5x squared minus 6x plus 7. And I want to take the first derivative of this. So what this becomes is the 5 drops down, subtract 1 from it, right? We're just going to be doing the power rule over and over again. So this becomes 10x to the fourth minus 12x cubed plus 10x minus 6, and then the 7 just goes away. Okay, and the x drops. So we're just doing power rule over and over again. So that's the first derivative, right? And so the second derivative, there's a different color. We're going to rewrite this as kind of those two little apostrophes. That means double prime, that means second derivative. Also, let me clean this up really quick. Okay, so if we take the second derivative this time, we're just going to take a derivative of the derivative, which is just the power rule all over again. So this becomes 40, 40x cubed minus 36x squared plus 10, right? Constant goes away, and then the x just drops. All right, and then power rule, that drops down, we subtract 1. Okay, so that's the second derivative, right? And now the third derivative, well, we're just going to take a derivative of the second derivative. So, this becomes 120x squared, right? Minus 72x. And then this 10 just goes away. It's a constant. But yeah, power rule, that drops down, subtract 1. That drops down, subtract 1. Okay, so that's our third derivative. Let me clean this up a bit. Last one, we want to find the fourth derivative. So one more, right? So the fourth derivative of x, right? You can also rewrite it as, like, if you want, a little tedious, but just 1, 2, 3, 4 of x. is just a derivative of this guy. So what that would become is just 240x minus 72. And that's our answer, right? We drop that down, subtract 1, and then the x just drops. All right, so that's our fourth derivative, and that is this example. Okay, so here's example 2 now. It says if f of x equals 1/3 x to the 6 minus 2x cubed minus 3x squared plus 7, we want to find the function evaluated at, kind of write that out. So we want to find this function evaluated at -3 for our original, our first derivative, and our second derivative. So what I want you to do in this first part is first find your first derivative and your second derivative. Okay, so give it a shot, see if you can do that. It's always easier to reset up that, or you know what, you could just do it right here below. It's always easier to just have it below. So go ahead and give it a shot and see if you can find your first and second derivatives, and we'll go over it. All right, welcome back. So hopefully you tried out your first and second derivatives. So what this is, right, power rule for all of these. So the 6 drops down. So you get 1/3 times 6x to the 5th minus 2 times 3x squared minus 3 times 2 to the x plus 0, right? Just power rule with everything. Drop that down, and then 7 just becomes a 0. So if we simplify this out, we get 2x to the 5th minus 6x squared minus 6x plus 0, which we leave like that. Okay, so that's our first derivative. All right, so I'm going to box this up so we know where that's at. Okay, and likewise, we want to find the second derivative. So we're just going to find the derivative of this guy right here. So power rule again, we get 10x to the 4th minus 12x minus 6. All right. So we have a first and second derivatives, and now that's the first part of the question. So now we need to plug in x equals -3. All right, so I need to find f of -3, f prime of -3, and f double prime of -3. Okay, so step 2. So I'm just going to plug in -3 into all these guys. So f of -3, right? I'm just going to plug it into the original, this guy right here. So this is 1/3 times -3 to the 6 minus 2 times -3 cubed, right? Minus 3 times -3 squared plus 7. Okay, so then I'll trust you with the calculations, but what this ends up being is 277. If you do all, you can do all that in your calculator, right? And you get 277. Okay. So that is f of -3. So let's go ahead and check out f prime of -3. So now I'm going to plug that into our derivative, same color coordination. All right, so that would be 2, that would be 2 times -3 to the 5th minus 6 times -3 squared minus 6 times -3. And once again, I trust you with the calculations. So this would become -522. Okay. And that's the evaluation that x equals -3 for the first derivative. Lastly, let's go and check out, plug the -3 into the second derivative. So this becomes 10 times -3 to the fourth minus 12 times -3 minus 6. All right, and once again, I'll trust you with the calculations, but what you end up with is 840. Okay, great. So that is that question. So we went through just finding four derivatives, and we went through finding the first two and then evaluating them respectively. So example 3 says horizontal tangent line. We're not really talking too much about higher order derivatives. It's kind of like uh, not necessarily too uh, connected to it. So I'm going to head and skip this example. But that's it for this video, and I'll see you next time. Thank you.